Ayan. So once again, good afternoon to everyone. So to those who haven't yet done so, paki-check ng ating Google Meet na chat box. You can find there the link para sa ating attendance rather for today. So kindly fill that one up while I go over our topic for today. So last time that we had our meeting, so we talked about our Lewis structure. The Lewis structure helped us to be able to represent our compounds. This time, we now go into our functional groups and how in the laboratory we can be able to test for the presence of a particular functional group. So there are a couple of functional groups that we have. I'm sure that in your lecture, you might have already gone into the functional groups already at this point. So a couple of functional groups that we have can be seen in our worksheet. So for this activity, we'll just focus on the first three. You have the alkyl group, the alkenyl group, and also your alkynyl group. So how we can differentiate them from one another is by our tests for unsaturation. So in this activity, so we have the following objective. So by doing this activity, we aim to determine the presence of a particular functional group in a sample by qualitative testing. Qualitative testing means that you simply test for the presence or absence. You're not trying to test how much of a particular thing there is, only whether that thing is present or not. So that's what we mean by qualitative testing. So now at this point, we move to our organic chemistry. So in organic chemistry, it's a very big na field of study. So to be able to navigate it, so we try to be able to divide all of the organic compounds by looking at their functional groups. So the definition of the functional group is in here in the worksheet. The functional group daw is a group of atoms responsible for the characteristic reactions of a particular family of organic compounds. The presence of a functional group determines the physical and chemical properties of an organic compound. So for instance, if we have our medicines, for example, so these medicines could have, for instance, the presence of a hydroxyl group. The hydroxyl group allows that particular compound in our medicine to be more soluble in our blood. Thus, it's more easy to be absorbed by our body. So hydroxyl groups are quite soluble in water compared to any other organic compound na has no or hydroxyl group present. So as noted, we'll focus first on the first three functional groups that we have. The alkyl group looks like this one. So you have in here a part of our entire organic compound. And if you notice, you just have carbons here. May carbon atom ka, bounded to another carbon atom, and puro single bonds lang meron between the carbon atoms. So that is our alkyl group. So an example of an alkyl group that we might be familiar with is butane. So butane, we encounter it commonly when we are cooking our food, for instance. So butane, along with propane, is one of the main components of our LPG that we use to be able to cook our food and boil our water. So in contrast, meron rin tayong alkenyl group. In here, the second one listed. In the alkenyl group, you might notice that you now have a double bond between the carbons. Kung titingnan natin mabuti, ang kada carbon in here, they all have 4 bonds each. Itong first carbon na ito, meron siyang 1, 2, 3, 4. So, it has complete octet. This second carbon, pareho lang rin. Meron siyang 1, 2, 3, 4. So complete octet pa rin. In our alkenyl group, complete octet pa rin sila, both na carbons. However, the two carbons that we have in here, they now possess a double bond. So in this carbon, on the left, meron kang 1, 2 single bonds and isang double bond. Same with the second carbon, meron kang 1, 2 single bond and a double bond in the middle. An example of a compound containing the alkenyl group is this one, E2-butene. So E2-butene is an example of a compound known as an alkene. So alkenes are organic compounds containing a C-C double bond. In contrast to an alkane, sa alkane, if you notice, lahat ng mga carbons, puro single bonds lang mayroon. So that's the difference between the two. Alkane, puro single bond. Alkene, meron siyang at least one double bond between sa mga carbons. So a common example of an alkene would be the ethylene gas. So maybe one of these days, siguro kung hindi kayo pupunta in a medical field, you might work in food industry. So ethylene gas is commonly used in food, particularly in bananas, in the banana plantation industry. Ang ethylene, ang purpose niya is it hastens the ripening of our bananas and our other na fruits. So typically, ang ethylene is being sprayed into, our bananas are being exposed to the ethylene, and that ethylene serves to make the ripening of that one faster so that you can more immediately eat the banana. So that's the alkene. The alkene contains the alkenyl group. And finally, the last na functional group that we'll focus for this particular discussion is the alkynyl group. Alkynyl group has this one in particular. Ang functional group niya is meron siyang carbon bonded to another carbon, and between the two carbons, meron kang triple bond. So that is the alkynyl group. So an example of an organic compound that contains the alkynyl group is your alkynes. So in particular, you have here pictured 1-butene. So in this 1-butene, you can see na meron kang carbon here sa pinakadulo, bonded to another carbon, and between them, mayroong triple bond. Again, kung bibilangin natin sila carefully, itong first na carbon na ito, the one that I am scrolling on, meron siyang 4 bonds, isang single bond, isang triple bond. And for this last carbon here, meron pa rin siyang 4. It has 1 triple bond and 1 single bond. So it still possesses a complete octet. So one particular example of an alkyne that we might be familiar with is if you go to a welding shop, for instance, so meron kang acetylene gas na ginagamit doon to be able to burn, or rather to be able to weld our metals together. So that is an example of an alkyne. So for today, we'll just focus on the first 3. The alkyl group, which is contained in the alkane, alkenyl group, which is contained sa ating alkene, and the alkynyl group, which is a part of the alkyne. So sa alkyl group, if you notice, itong carbons natin ngayon, puro sila mga single bonds lang mayroon. This carbon, right over here, puro single bond. This one is puro single bond. and this one, and finally this one. So alkanes, they are what you call as a saturated hydrocarbon. By saturated, we mean to say na, sorry, saturated, we mean to say na it has the maximum number of hydrogens it can bond with. And by a hydrocarbon, we mean to say na ang alkene natin, this organic compound, contains only carbon and hydrogen. So there are no other compounds no other atoms rather that you can see. So only carbon and hydrogen is present. So this is an example of a saturated hydrocarbon. In contrast, sa ating alkane, itong alkene natin sa baba, like for instance this one, if you notice, this carbon over here that I'm pointing at, so hindi siya nag-contain ng maximum of 4 hydrogens. Meron lamang siyang isang hydrogen na bonded niya with, and yung isang hydrogen na pwede niya sana makabond with, napunta to make the double bond. So the alkenes, this is an example of an unsaturated hydrocarbon. Hydrocarbon pa rin siya because, again, as you can see, in this Lewis structure natin, there are only hydrogens and carbons present. However, unsaturated na because itong carbons natin sa gitna, it doesn't contain the maximum hydrogens na possible yan na makabond with. So instead of having 2 hydrogens here, itong ating carbon na ito, meron lamang siyang isa. Same with this one, instead of bonding with 2 hydrogens maximum, it only bonds with 1. So that is an example of an unsaturated hydrocarbon. Same with our alkynes. Our alkynes here, if you notice, itong carbons involved in the triple bond, so wala talaga silang hydrogen whatsoever. So our alkynes are also unsaturated hydrocarbons. So the tests that we're trying to do for this activity, it allows us to differentiate whether, kung may sample ba tayo, do we have an alkane, that is a saturated hydrocarbon, or meron ba tayong unsaturated hydrocarbon, tulad ng alkene or ng alkyne. So that's what we're trying to do for this particular na activity. So this worksheet, it will be made available lang sa Quipper. So you can download it there. So again, answer this one by group. So you have to go to this link to open the virtual lab simulator. Once you open the virtual lab simulator, you will be led to this page. And then we now have to select the type of test we're trying to do. So i-click nyo lang itong first na drop box, select unsaturation, and then the first thing we try is the bromine water test to help us differentiate the saturated hydrocarbon from the unsaturated hydrocarbon. So you have to observe what the results are for the bromine test. After you're done doing the test, write down your answers in table 1 as to what observations you were able to see when doing the bromine water test. So there's a second test we need to do. After the bromine water test, we also have to do the Bayer's test. So same pa rin, we use the simulator that we have, click the select the test drop-down list, select Bayer's test, and then we try to do the following na activity. So by doing this activity, we might have some observations as to what happened to our sample. So whatever it is we observe, our sample undergoes. So you write it down dito sa ating table 2. So what have you observed after adding the alkaline potassium permanganate? And what did you observe happened after shaking the test tube? So you have to fill in this table right here. So that's for your data. So once you're done filling in the data, so by the way, you can just assign 2 people to do the bromine water test and the Bayer's test. So they can fill this one up. But highly encouraged na everybody should be able to do the bromine water test. So at least be sure na every member of the group has tried to do the bromine water and the Bayer's test. Para familiar kayo what observations we see when doing this one. But only one person needs to fill up itong table na ito. So for the rest of the team, so they can now contribute by answering the discussion questions. So fill in your answers here in the box for each discussion question. And be sure to list down your references in here below. So be sure to use the APA citation format. So all in all, this activity is worth 70 points for this worksheet. Okay? So with regards to our activity, so any questions ba as to what we're supposed to do for this one? Okay, so Iso and Julian says none. Okay. Sige. So let me stop this presentation and go to the other PowerPoint. So again, you can just download the worksheet sa ating Quipper. So as soon as you can, please be able to do the activity on our virtual lab simulator. And then a week from now, so you're supposed to submit the answered na worksheet for the group. So with that, after having discussed the worksheet, so now let's also talk a little bit about our organic compounds. So again, I'm sure that you've already been doing this one sa ating lecture sa chemistry. But let's just try to go over it very quickly lang para sa ating lab so that we have a better idea as to what these organic compounds are after all. So our carbon daw, according to this PowerPoint, it forms covalent bonds in all its elemental forms. So carbon has an electronegativity of 2.5, which is halfway between the metals. Ang mga metals, mga around 1 lang siya or less. And the non-metals, which have greater than 2.5. So ang carbon natin, it prefers to share electrons. So by sharing electrons, our carbon is able to form four bonds, four covalent bonds total. By forming these four covalent bonds rather, our carbon is able to achieve our complete octet. Now, our carbon, when it forms its chemical bonds with other carbon atoms, it's able to exhibit catenation. So this is the ability to bond to itself and form a stable chain, a ring, and branch compounds. So this is quite important because ang lahat ng ating life on Earth, they are all based on carbon compounds. And because our carbon is able to form stable chains, rings, and branch compounds, this allows our carbon to be able to support a wide variety of compounds necessary for life to occur. So if you might recall, we had our periodic table presented to you last time. So right below sa carbon, sa kanyang group, if you could recall, we have silicon in there. Silicon is actually one candidate for the building block of life on other planets. However, ang silicon, it's not as strong and as stable when making chains as carbon. So, it's possibly not something that we expect life on Earth to have in its particular na structure. So ayan, carbon is right over here. Below it, silicon. Silicon can also form four bonds. However, the silicon bonds to the other silicon atoms, it's not so very strong. So it's not a really good contender for the building block of life on Earth. So the strength and the stability of the carbon-carbon na bond allows us to be able to form a wide variety of mga compounds. So if I recall correctly, there are already mga hundreds of millions of organic compounds that have been discovered. So a great variety of them have been synthesized in the laboratory. For instance, a particular na very important carbon compound or organic compound will be our penicillin. So it is a drug that was discovered before the World War natin, and it was able to address the bacterial infections that our soldiers have. So before then, if magkasugat ka lang ng kaunti, so it could potentially be fatal. But by using penicillin and all the other antibiotics that followed, so we were able to improve the quality of life for all kinds of people all over the world. So penicillin and all of those drugs that we have, so they are found in nature, but actually these days, so they are most commonly synthesized in the laboratory. Mas madali siya i-synthesize lang because, as you can imagine, so ang dami-daming tao sa world, and for you to be able to give cheap antibiotics na available to all, kailangan mo ng napakarami na sources of that one, which that our nature is really unable to provide. So for us to be able to give them cheap medicines, it's much easier to just make it in the laboratory. So really, that is the miracle of organic chemistry in our modern times. So it allows us to make a wide variety of organic compounds that have a very great effect on the lives of millions of people all over the world. So aside from our hydrocarbons that were pointed out kanina, so there are also other organic compounds that contain heteroatoms. Heteroatoms, so these are the atoms that are not carbon and hydrogen. So aside from carbon and hydrogen, ang common natin nakikita in organic molecules are oxygen, the O atom, nitrogen, and the halogens, namely chlorine, fluorine, bromine, and iodine. So our organic molecules, they're able to undergo chemical reactions by the interaction of electron-rich areas in one molecule with an electron-poor site in another. So as you can see here, we have a couple of varieties of mga organic compounds. So it's a little bit small, but as you can see, there are really quite a lot. And these are only the simple organic compounds. The medicines that we take, for instance, or the vitamins that we take in the morning, so they are much more complicated organic compounds that we have. So much more complicated than this. So common sa lahat ng ito is the carbon skeleton. So the carbon skeleton is made up of carbons that are bonded together like this. So in that carbon skeleton, the groups are joined by a single bond that can rotate, so that there are often several different arrangements of a given carbon skeleton that are equivalent. So the important thing here is that ang pagkadugtong-dugtong lang ng mga carbon atoms. For instance, in here, this first arrangement here that you can see in a ball and stick model, it looks like this. This one here is the same as this one. So they are the same because ang arrangement ng carbons is just the same. Meron kang isang carbon connected to another carbon, which is connected to another carbon, na connected na naman to another carbon. Ito siya, similar lang naman, carbon connected to carbon, connected to another carbon, and finally connected to yet another carbon. So this one here, this one, the first one natin, and the second one, they are just the same. However, itong ating first one, ito siya, it's no longer the same as this. So why are they different? It's because ang arrangement nila is no longer the same. Sa first natin na picture here, you can see na kada isang carbon lang naka-attach sa kanya. So this one, isang carbon lang ang kasunod niya. This one, meron naman siyang kasunod na isa. So actually, dalawa na kanyang nakabanding with. And this one, meron siyang kabanding na isa pa. So that this one here in the middle, meron siyang dalawang carbons attached to it. Compared to this one, so if you look at the similarity nila, pareho lang apat ang carbons. But this one, sa ikatatlo, you can see here na itong central na carbon na nandito, meron na siyang tatlong carbons na connected sa kanya. Whereas here, in the first one, ang pagka-connect-connect lang ng atoms is puro single or double connections lang. So this one here is not the same as the third one right over here. So how they are drawn is not an indication that they are the same, but rather we just simply look at how the carbons are connected to one another. That we can determine whether a particular organic compound is the same just by looking at the carbon skeletons. So in here, you have some examples pa of other na carbon skeletons with 5 carbons. So as you can see, just having 5 carbons allows us to be able to form a wide variety of carbon skeletons in which you can now build a particular na molecule. Kung bibilangin ko, meron tayong 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 possible different arrangements of carbons, 5 carbons in a skeleton. So all of this can make different compounds to one another. So again, the key when drawing the carbon skeletons, just remember, each carbon atom, meron lang dapat siyang maximum of 4 bonds. So any less than 4 bonds or greater than 4 bonds, so that's already a mistake. You might have 4 single bonds. Pwede kang meron kang isang 1 double and 2 single bonds. Pwede rin meron tayong 1 triple and 1 single bond. Basta ang importante lang, when we sum it all up, so there should be a total of 4 bonds in there for each carbon atom. So the arrangement of carbon atoms determines the skeleton. So a straight chain and a bent chain represent the same skeleton. So it all depends on how the carbon atoms are bonded to one another. Which is why, as we can see, this one here is not the same as this one over here. But this one is the same as this one. Since pareho lang ang pagkaka-arrange ng carbon atoms in the second one and in the first one. Okay, so skip natin iyan. Okay, skip rin natin ito. So you have your alkanes. Again, our alkanes are hydrocarbons, meaning it only has carbon and hydrogen. Alkanes are hydrocarbons that have only single bonds. And they are what you call as saturated hydrocarbons. The general formula for an alkane is this one, CnH2n plus 2, where n is any positive integer. So for instance, if you have, for example, 5 carbon atoms in total, and you want to be able to find, for example, what is the formula for an alkane with 5 carbon atoms. So gagamitin mo lang ang formula na ito. So 2n plus 2, itong nasa formula na ito, that tells us the number of hydrogens that we have. So number of hydrogens is given by this one. In this example, ang sabi niya is the alkane has 5 carbon atoms. So what we do is we replace the n with 5. Sige nga, can I please ask you guys, can you please compute for me how much ba itong 2 times 5 plus 2? So kindly please compute for me how much this is. So how much is 2 times 5 plus 2? Okay, thank you, Micah. So that is 12. Also John as well, that's 12. So therefore, in this alkane na merong 5 carbon atoms, meron dapat siyang 12 hydrogen atoms total. So therefore, ang formula ng ating alkane na ito with 5 carbon atoms. Therefore, we can now say this alkane has the formula, copy ko lang, C5. Again, ang 5 is our N in this example. And since meron tayong 12 H atoms, so you now have C5H12. So that is now our formula for an alkane with 5 carbon atoms. So at this point, let's try to test another example na naman. So at this time, so please tell me now, what is the formula for an alkane with 3 carbon atoms? Can you please type sa chat box, ano bang formula for this alkane? Okay. So I think number of H atoms yan dyan. But what I'm looking for is the formula na mismo. So please type sa chat box, ano ba ang formula ng alkane na ito? With the formula, with 3 carbon atoms in this particular alkane. Okay, so if you check the chat box, so Deborah has the correct answer for this one. So ang formula niya is C3, since meron tayong 3 carbon atoms. And using the formula here, 2n plus 2, meron tayong dapat 8 H atoms. So this one is C3H8. So that is how we can find the formula for any alkane. So of course, ang chemical formula is quite good, but it's much easier to just name the organic compounds by a particular name. So dito papasok ang ating naming. The way that we name an organic compound is by using 3 portions. So meron tayong prefix, plus connected to it is the root, and the suffix. So the root here tells us the number of carbon atoms in the longest continuous chain. Suffix indicates the type of organic compound and is placed after the root. So if alkanes ang pinag-uusapan, ang suffix niya is ane. So that's A-N-E. And the prefix identifies any groups that are attached to the main chain. So by the way, this one is shared lang naman sa ating Quipper. So you can just be able to download this PowerPoint there. So what we need to do is we have to familiarize these roots in here. So for example, copy ko ito sila. If we want to name, for example, C5H12, Move ko ito siya to the side. So C5H12, it is named as follows. So looking at the list of roots that we have, meron tayong 5 carbons daw sa ating formula. So pag may 5 carbons, ang root name is pent. So the name of this one is pentane. Again, ang ane dito is the suffix. So lahat ng alkanes, ito ang kanyang suffix na mayroon siya. So that is now the name of C5H12 that is called as pentane. Okay, so at this point, let me turn it over to you guys. So again, please refer to our table in here. So this time, what I'd like you to do is, kindly name for me, ano ba ang name ng ating C3H8? So again, the format for the name is root and ang kanyang and sumpay sa kanya is the suffix na ane. Kaya siya naging pentane because ang root, so first example is pent, and ang suffix is ane. So root plus suffix gives us our name, pentane. Okay, so we have John with the answer for this one. C3H8 is our propane. So bakit propane ang pangalan niya dyan for this one?
Kasi po sure meron siyang tatlong carbon. Then yung niya group niya is alkane.
Okay, so that's correct. So thank you so much. So since tatlo ang carbons niya, ang root is prop. And it belongs to the alkane, kaya ang dulo niya is ane. Now let's try a different example na naman at this point. So let's say we have the following. So now that we have the list of roots and we already understood how to name our alkanes, let's say we now have this example. So this time, what is now the formula for for our octane? So to answer this one, again, we just have to look at the root. Ang root niya is oct. Oct has 8 carbon atoms. So copy ko ito. So oct tells us that there are 8 carbon atoms. And using the formula from earlier, CnH2n plus 2, we can then compute the number of each atoms. So 2 times 8 plus 2 gives me, so how much ba ito? 2 times 8 is 16 plus 2 gives me 18. For this example, the formula for octane is C8H18. By the way, octane is the main na component ng ating gasoline that powers our cars. So that is one particular example of an octane. So this time, what I'd like you to do is, please try to answer this one for me. Let's say we now have this one. Copy ko lang para mas madali. So this time, please tell me the formula for nonene. So first, tell me muna sa chat box, ano ba ang, how many carbon atoms ba mayroon kay nonene? Okay, so Lourdes has that one correct. Same with Jamuel. So meron siyang 9 carbon atoms. This time, please tell me how many hydrogen atoms mayroon si nonene. So again, use the formula that we have here, 2n plus 2. So Lourdes, Cristel, Iso have that one correct, and Jamuel as well. So that, taken together, ang formula ni nonene is, please don't hang, C9H20. As Cristel and Jamuel have pointed out. So that is the formula for that one. Okay? So for this one, any questions ba on how to name our alkanes? Okay, so Crystal says none. How about the rest? Follow lang ba? Paano i-name ang alkanes? Sige. So thank you so much for the feedback. So let's proceed to the next na slide. So you have a more comprehensive way of naming the organic compound. So it is presented right over here. So I think the best way for this is, let's just try to have an example lang. So let's say we have this one right over here. Tanggalin ko siya kay giveaway. So una natin gagawin here, titingnan natin ang Lewis structure or ang tinatawag na expanded formula, and titingnan natin ano bang pinakamahabang connection ng carbon atoms in here. Again, please don't hang. Ayaw hang, please. Ayan. So kung titingnan natin mabuti, the longest connection of carbon atoms here looks like it is this one. So in this chain of carbon atoms, so kung bibilangin natin lahat, how many carbon atoms there are, meron tayong 1, 2, 3, 4, 5, 6. So that is the longest chain that we have. So let me have the text box. Pag 6 carbon atoms, copy ko na lang ito para meron tayong guide. So since meron tayong 6 carbon atoms here in the longest chain, so base sa ating table of roots, so 6 carbon atoms is having a root of hex. Hexane, more particularly. Okay? So that's the first step. First step, we identify ano ba pinakamahabang connection of carbon atoms there are. The second step here, let me label this one properly so that we have a guide on what is happening. So this here is the longest chain that we have. So this is the longest chain. Ating longest chain, you can see na meron kang mga parts that are connected to it. So for example, meron ka dito connected in this one. You have in here this part sa taas. Meron kang nag-iisang carbon. Let's label this one differently. So let's say we color this one as blue. Ito siya. So this carbon in here, basically, it's kind of like it's substituted for the hydrogen na normally, kung hexane lamang ito na simple, dapat H lang ito. But this carbon has substituted for that hydrogen. Which is why this one here, the one that I put in the box, this is what you call as the substituent. So this is the substituent. So it's called substituent because instead of hydrogen in the normal hexane, so this carbon substituted for that particular na hydrogen. So that is this particular substituent. And moving down the line, we can see another substituent na naman sa ating number 3 na carbon. Instead of this carbon here, sa ikatatlo, bonded to a hydrogen, this carbon is instead connected to yet another carbon atom. In fact, there are 2 carbon atoms here. So this one is also another substituent. So let's call the substituent sa taas as substituent number 1 and the one sa baba as substituent number 2. Para lang klaro ang ating list. Oops. Let me color code this one. Itong hexane refers to the name ng longest chain. This time, itry natin pangalanan itong substituents natin. Start tayo kay first substituent. For the first substituent, ang pangalan nito is the meth. Meth because, as you can see, 1 carbon atom lamang siya. And para maiba siya sa alkane, ang suffix nito rather is -il. So this is the methyl group. Okay? So how to name the substituent? Similar lang siya sa ating alkane. Titingnan mo lang how many carbon atoms there are. So that tells you the root. And after the root, ilalagay mo lang ang suffix na "il". So this is called as the methyl group. So this time, what I'd like you to do is, can you please name for me, ano ba pangalan nitong substituent number 2? So the one on the box below. Okay, so Crystal has that one right. So this is the ethyl. Crystal, would you like to explain to the class bakit ethyl ang pangalan niya?
Dalawa yung carbon atom, sir.
Okay, so that's correct. Since dalawang carbon atoms, ang root niya is F. And since substituent ito siya, ang kanyang suffix is "il". So meron tayong isang ethyl and meron tayong isang methyl. So to be able to name this compound in here, we simply have to cite the substituents. Alphabetical order lang. Itong isa, ethyl ang pangalan, so E ang start. This one starts with M. So alphabetizing this one, we first write ethyl. So ethyl is the first substituent. Then the next substituent is methyl. So what we have here is the ethyl-methyl hexane. So that is how we name our alkanes that are said to be branched. So pag branch na siya, meron na siyang substituents present. So how do we do this one? Una muna natin gagawin is we identify the longest chain, what we call as the parent chain in this example. Pag napangalanan na sa parent chain, then we identify what substituents there are. So the one in red is the name of the parent chain. And on the blue, we alphabetize the names of our substituents. Kaya siya ethyl muna bago methyl. Okay? Oops. Ayaw hang, please. And finally, to completely finish this one off, kailangan muna natin i-indicate saan ba nakaposition si ethyl and saan ba nakaposition si methyl. Because here, sa pangalan lang na ito, we have no way of knowing saan banda si ethyl makikita sa ating parent chain. Similarly, we also don't know saan banda nakakabit si methyl na group. So in the parent chain, kailangan natin na i-number ang kada carbon atoms. Beginning sa pinakadulo, wherein ang mga substituents will have the smallest possible na number. So let me make this one smaller lang. So on the left, we have carbon number 1, carbon number 2, 3, 4, 5, and 6. So si methyl, as you can see, nakakabit siya kay carbon number 2. So sa ating pangalan, we have to put a dash in here. So dash 2. And this 2 na number indicates to us to which carbon the methyl is connected to. Now for this one, for the ethyl group, So can you tell me to what carbon atom is the ethyl group connected to? Crystal has her answer. How about the rest? So to what carbon in the parent is the ethyl connected to? So please type your answer sa chat box. So we have Ivy and John agreeing with Crystal. So si ethyl nakakabit siya kay carbon number 3. So this time, we have to put another number before ethyl. So this is 3-ethyl. And ito na ngayon ang complete name ng compound na ito. So this one is 3-ethyl 2-methyl hexane. So that is our compound right over here. So that is the Lewis structure for this one. But there are other easier ways to represent this one. Obviously, as you can see, it's quite tiresome to have to draw all of the bonds in this Lewis structure. So pwede mo siyang i-condense. So in the condensed formula, ang naka-emphasize lang dito is the connections of the carbon atoms. That's what we can immediately see using the condensed formula. And there's an even simpler way to represent our 3-ethyl 2-methyl hexane. So instead, we can now use the carbon skeleton formula sa pinakababa. In this one, ang kada dulo and kada point in here sa linya na ito, each point in here represents one carbon atom. So that, for example, this one, sa pinakadulo nito is one carbon atom. And we can also have another carbon atom right over here. So this is yet another carbon atom. So kung bibilangin ko ito lahat ng mga dulo ng linya na ito that we have, meron tayong 1, 2, 3, 4, 5, 6. So, pareho siya ng parent as our Lewis structure sa taas. Sa second na carbon, we can see na meron siyang isang carbon atom na naka-attach. So itong dulo ng linya na ito is another carbon atom. And right over here, kay carbon number 3, meron ka nakakabit na 1, 2 carbons. So each point in here represents a carbon atom. So this one is the 2-methyl. And itong andito, this is the 3-ethyl. So in here, we just simply disregard all of the hydrogens. And ang kada carbon atoms is just represented by the ends and the middle ng kada linya. So that's the carbon skeleton formula. So definitely out of the three, the expanded Lewis structure, the condensed formula, and carbon skeleton formula, ito siya pinakamadali na i-draw out of all of them. So that at least di ka na matagalan in drawing this one. So let's see if we have another example here. So let's say, let me find this particular example. So for a while lang, while I copy this one. Uy, please don't hang. So this time, let's say we have the following. So again, please be mindful of the steps in how we name the branch alkane. So let me type it in here. Steps in naming branch alkane. So unang-una, you have to first be able to one, name the parent chain. Second step, name the substituents. 3, alphabetize the name ng substituents. And 4, we have to locate the position of the substituents. So, unang-una muna, step 1. So can you please name the parent chain for me? Okay, so ang name ng parent is heptane. So John got that one correct. So maybe I can have another person answering step 2. So can you please name the substituents for me? So a different person na naman this time. So ano bang pangalan ng substituents natin dito? So what are the names of the substituents that we have? Okay, so again, pag substituent, Stephanie, ang kanyang suffix is il, hindi in. So pangalan niya dapat is ethyl and methyl. That's already alphabetized for us. Mauuna si E before M. And finally, let's locate the position of the substituents. Now you can try to number this one from left to right. 1, 2, 3, 4, 5, 6, 7 sa ating parent chain. However, the better way to number this is mag-umpisa tayo sa right side. So you might wonder bakit sa right side? Ang gusto natin ngayon is dapat ang substituents natin, ang kanilang location should be the smallest possible number. So if I do it like this, ang ating methyl nasa carbon number 2. At si ethyl nasa carbon number 3. If you try to do it in a different direction, if you number it from left to right, so ngayon meron tayong 1, 2, 3, 4, 5. So si ethyl, so number 5 na siya ngayon. And this one is number 6. So masyado nang malaki ang number. So mas better na ganito ang numbering na ipo-follow natin. So that our substituents have the smallest possible number. So this one, so ethyl is in number 3. And si methyl nasa number 2. So the name of this one is 3-ethyl 2-methyl heptane. Yung answer ni John earlier is already correct. Okay, so these are the 4 steps that we observe in naming the branch alkanes. So let's say, now have this one. So let's say I have the following. So looking at this structure over here, so can you please name this one for me? Again, please use the steps that we have right over here. Please type your answers at chat box. So what is the name of our second compound? So you might want to follow step by step. First step, name the parent. Second step, name the substituent. Third step, alphabetize. And fourth step, determine the location so that they have the smallest possible number. So after doing the four steps, so kindly tell me the name of this one. So any guesses? Anong name ng ating second compound? Okay. So meron tayong isang answer dito. So can I see from the rest of the class? So what is your answer for this one? What is the name of this compound? So any other answers? Are we still here? Sige. So this one is actually named to be 5 propyl decane. So it is 5 propyl decane because first, according to step 1, ang name ng parent nito is decane. Meron tayong 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, kaya siya naging decane. Now, connected to the decane, meron kang, ito siya, this one connected to it. So this one, it has 1, 2, 3. 3 carbons, kaya siya naging propyl. And finally, so the propyl group is in carbon number 5 because if bibilangin natin from left to right, 1, 2, 3, 4, 5. Kung bibilangin natin from the other side, sa right side going to the left, this is 1, 2, 3, 4, 5, 6. Ang gusto natin is, si substituent, dapat smallest possible number siya. Kaya, in the end, pinapangalanan natin siya na 5-propyl decane. Since 5, counting from left to right, is smaller than 6 if you count from right to left. So that's 5-propyl decane. Now, there are some substituents wherein we have the following. A particular substituent may appear more than once. So if more than one of a particular substituent is present, use the prefix di, meaning meron tayong dalawang substituent na same. Tri, meaning tatlo na siya. Or tetra, meaning there are now 4. So that is the additional na step that we can follow for this one. So let's say I now have this one last example. So again, first step, kindly tell me ano ba pangalan ng parent chain for this one over here. Okay, so medyo may disagreement tayo. Sabi ni Iso, heptane, same with Julian and John. Christel says hexane. So for me, kung bibilangin ko ito, meron tayong 1, 2, 3, 4, 5, 6, 7. So this should be heptane for the parent. Next, pangalanan natin ano ba ang substituents na mayroon tayo. So can you please tell me now for this example, ano bang substituents meron tayo for this one? So that is step 2. So kindly tell me the names ng substituents for this one. Okay. So medyo advanced siya. So I'm just looking for the names muna. So ang names nila is, meron tayong methyl. So this is methyl over here. And this one over here is also methyl. Methyl rather. And finally, this one is ethyl. Now notice, meron tayong dalawang methyl na present. This one here and this one over here. So what we do is, we have to write this one as follows. Ethyl pa rin mauuna, since ethyl starts with E. And since meron tayong dalawang methyl, ito siya is methyl, this one is also methyl, we have to call this one as dimethyl. Now you might be wondering, Sir, D dapat mauna siya from E, di ba? But, ang tinitingnan natin is ang pangalan mismo ng substituent. Ang substituents are ethyl and methyl. So, hindi natin tinitingnan ang pangalan ng prefix. Kaya siya ngayon dapat nakasulat as ethyl first, followed by dimethyl. Since ang dimethyl, ang substituent niya is starting with letter M. And finally, for the numbering for this one, so pwede natin i-count ang numbers from right to left or from left to right. So let's see what happens. So kung magbibilang tayo from left to right, so we now have the following. We have 1, 2, 3, 4, 5, 6, 7. So ang ating dalawang methyls, nasa 2 and 3 sila. So what I do is, the numbers here should be the following. So ang methyl natin makikita sa number 2 and sa number 3. And si ethyl, we can find it in number 5. So I now have to type in 5-ethyl. So this is now the name of this particular alkane. 5-ethyl, 2,3-dimethyl heptane. So if you have any doubts kung tama ba ang numbering nito, you can try to compare this one. Let's say if nag-counting tayo from right to left this time. One easy trick that you can do to determine kung ano bang tamang numbering is pwede mong i-suma total lahat ng numbers that we have in the name. Let's say if you count from right to left, and assuming yan ang tama na pangalan, the alternate name would be this one. So counting off from right to left, so ang ating ethyl ngayon becomes 3 ethyl. And our methyl is nasa numbers 5 and 6. So if you're not sure ano ba ang ating tamang name for this one? What you can do is you can add all of these numbers together. So 5 plus 2 plus 3 gives me a total of 10. So the alternate name, meron kang 3, 5, 6. If you count it from right to left, again, you can just total the numbers in here. So 3 plus 5 plus 6. So can you please total that one for me? So how much bang 3 plus 5 plus 6? Okay, so Julian and Jamewell give us 14. So if hindi ka sure ano ba ang tamang numbers na gagamitin, you can just add up the total numbers and whichever number is smallest, ito siyang masusunod. So since this one, ang total ng numbers is 10, compared to this one, which is 14, so this is the correct name. So it should be named 5-ethyl 2,3-dimethyl heptane. The reason is because ang sum ng mga numbers na ito is smaller compared to the sum of the numbers here in the alternate name. 3 plus 5 plus 6 is greater than 5 plus 2 plus 3. This tells you na ito ang tamang pangalan for this one. So that is how you name your branched alkane. Okay, so with this one, are there any questions ba on how to do this one? Any parts that you find are not easy to follow? Okay, so Iso has her answer, same with Cristel. So thank you for the feedback. So this particular na synchronous session will be made available lang sa Quipper. So if you have difficulty, you can just rewatch this one so that you have a guide on what to do. So again, please check Quipper for the recording of this one, our worksheet for this week, and our assignment for this week as well. So with that, so let me stop the recording now. So thank you so much for your active participation for today. It's now 5:46.